It's like, I don't hear.
What you need?
Accent.
No,
Sometimes my farmer
Wait.
accent comes out.
Well, why not?
Should I download it then?
Yeah, I always think downloading is probably a little bit better, but you just because you just opened up into your mail,
That's pretty
right?
much up to
Yeah, you probably have to. Did you just hit start slideshow?
Yeah.
Go to that. When it opens up, because that's not actually.
But then you end up talking.
That's giving a slideshow inside your email, not through PowerPoint itself. So it's always going to only use whatever is being used by the email. I don't think it can take over its screen.
Aren't they for history longer than 5 minutes a little bit?
Yeah. I decided I'm not really going to do anything. I mean, we're going to look at geometry, but I'm not rushing. We'll get over geometry today and Thursday. I'm not doing anything else. I don't even have any homework.
It felt like you cut a lot out to try.
Oh, yeah. The only thing you have to do is prepare for final, and I should tell you about maybe 2/3 of the way done. Do your final, but I've decided that you can have all of your notes and assessments as resources.
Hopefully within-
So like all the slides?
Yep. Any of that stuff that you want. I'll give you some more
That's for
details on
each
it.
slide.
I mean, it's just not that important to memorize all that crap, right? So. I forget half of it. Even
That
after
is
I teach it.
teachable.
Oh, let me see. What's your name?
You put John down, just in case I mess up.
Nachos.
Not sure what you
Well,
bring.
what if you do really well? Then
Or we can put hyphen my name, so my name is good.
Anytime you're ready,
Okay.
you have an audience of 3. Or Maddie, she has a fever.
So for our bellowing, I want you guys to think, pair, share about what do you think of when you hear the word slope. So take a minute, think to yourself, and then discuss with your neighbors.
Skis.
We're gonna have to do it as one group, aren't they?
Yeah.
What do you call them? Ski slope?
Yeah.
Gary, you look like you have an idea? What do you think of?
I think of like, when I hear the word slope, I think of like just a ski slope that you go down. It's a downhill
Okay.
kind of,
Yeah. What about you, John?
Yeah, I said on the slide.
Like a slide? So it looks like a lot of downhill slopes, right? Do you think a slope could go uphill?
yeah.
Go up the slopes.
Yeah, you,
Yeah. Alright, well today we're going to be talking about slope and slopes of lines. So for our objectives, Colin, can you read the first one?
Explain the ratio that represents the slope of a line.
Alright, so for that, a ratio we know can be set as a proportion or it can be set as a fraction, right? So we're going to have the ratio of one value to another value, and that's going to determine the slope of a line for us. Gary, can you read number 2?
solve for the slope using the given formula.
Alright, so in a minute, there's going to be a specific formula that we can use using 2 points on a line that will tell us the slope of the line. John, number 3?
Determine the slope from graphical representation.
That's a big word. So for that one, I'm going to put up pictures of graphs on here, and without even using any points, we're going to determine like if a slope's positive, negative, what the slope's going to be just by looking at a graph. And Gary, can you read number 4?
Understand the difference between positive, negative, 0, and undefined slope.
Alright, so for that, there are 4 different types of slope that we're going to be learning about later on through the lesson. Alright, so make sure you write this down. The slope describes the steepness of a line, which relates to what you guys are talking about when you go down a slope for skiing. Remember, if you have a steeper slope, you're going to go faster. Some of them are more shallow slopes. And the steepness is the ratio between the rise and the run. So to find the rise, it is also the vertical change. So we're using graphs here. So if we draw our coordinates, we have our y-axis and our x-axis. So when you think of rise, do you think of an up and down motion or a left to right motion?
Up and down.
Up and down?
Yeah.
Because that's our vertical change. And when we think of the change in something, we think of the difference between two things. So rise is going to be the change in x, sorry, the change in y. Which is also the difference in two y values. And then if we go on over to run, so if rise is our vertical change, then run is going to be our horizontal change, which is going to be the change in x. So it's going to be the difference between two x values. So the slope formula that we're going to use is just putting the ratio into the terms that we determined over there. So we're doing the change in y, which is just the difference between 2 points in y, and the change in x, which is just the difference between two x values. And the ratio of that, the y over the x, gives us the slope of the line. So this is a very important formula. You guys want to have this written down in your notes. Another important statement that goes with this, to use this formula, we have to know at least 2 points on the line. Now you can have a graph of a line that you can see all the points and just pick 2 of them, but you have to know at least 2 points. So when we're putting this formula into use, we need 2 points, and we need to label them x and y. Sorry, x1, y1, and x2, y2. So say we have the points 1, 2, and 3, 4. And which one do you guys want to make x1, y1, and which one do you want to make x2, y2?
The first one.
You want to make this one x1 and y1?
Yes.
Alright. So if we have x1, y1 equals 1, 2, and x2, y2 equal to 3, 4. We're going to go and plug that into our formula. So we have m is equal to our y2 value, which is 4, minus our y1 value, which is 2, over top of x2, which is 3, minus x1, which is 1. So our numerator comes out to be 2. And our denominator comes out to be 2. So we end up with a slope of 1. Now, what do you guys would think would happen if we put x1, y1 equals 3/4, or 3, 4? Do you think we'd get a different slope? Do you think we'd have the same slope? John?
A little bit different because it'll be negative.
It could be. Let's plug it in and find out. So we want our x1.
And say experience tells you that's what most kids say. So you have to be prepared to show
We
it.
got something like that.
So we're going to make our x1 3, 4 now. And our x2, y2 is going to equal 1, 2. So now let's go and plug this into the formula. So we have m equals y2, which is now 2, minus y1, which is 4, x2, which is 1, minus x1, which is 3. Can anybody tell me what you end up with?
Get 2.
We have -2
Negative, sorry. Yeah,
over -2, and the negatives cancel out because they're on top of each other, and we end up with +1.
John just got
That's cool. So that just goes to show, it doesn't matter which order, like which point you make x1, y1, or x2, y2. The only thing that matters is that you keep the ordered pair together. So if you make 3, 4, if you make 4, y2, 3 has to be x2. You just gotta keep your ordered pairs stuck together. Alright. Alright, so now try this one on your own. You're gonna find the slope between the points 3, 2, and 7, 5. Determine which one you want to be your x1, y1, x2, y2, and then plug it into your formula. Alright. Colin, can you walk me through the steps you did?
So I chose 3, 2 as my x1, y1.
Okay.
So it'd be y2 minus y1, which is 5 minus 2 on top. And then 7 minus 3 on the bottom.
Alright, what does that come out to?
3 over 4.
And what that just goes to show you is that the slope doesn't have to be in the integer form. It doesn't always have to come out to the 2 over 2 and simplify down to 1, or 2 over 1 and come out to 2. It can be in fraction form, because when it comes down to it, we have to remember that the slope is the ratio between two terms, being the change in the y over the change in the x. Alright. So now I'm going to give you 2 more to do with yourself, and when you're done, share with your partner. So we have points 0, 2, and 1, 4. And 1, 4, and 2, 3. When you're done, talk with your neighbor. John, do you wanna come up here and solve number 3 for us?
Sure.
Do you need some help?
No,
You gotta know figure it out.
yeah. I just put my X's at first and then couldn't do 2 minus 4.
Okay.
Yeah.
Is that,
Did you mess up?
Now, yeah.
well, why do you have the plus there?
Yeah, I guess.
Okay.
We're almost there.
Did you flip it around?
Yeah, I'm gonna use.
Okay. At least you caught yourself. Oh, here, just take a quick look at the formula.
Oh,
So you have them labeled under there,
Y2.
x1, y1, x2, y2.
Y1, and then it's x2.
There you go.
X1.
Good job, John.
So yeah, he was just flipping up and he was starting to do y2 minus x2. But you have to make sure you want your y's to go together, your x's to go together, right? So you guys have to be careful for that. And you can always refer back to your formula, that's not on the one. Alright, did we all end up with 2 for that one?
Yeah.
Alright. Colin, do you want to come up and do number 4 for me?
Yeah. Should I label it like he did?
Yeah. Very good. Do we all end up with -1 here?
Yeah, that's what I got.
Yeah, because we don't have any negative in the bottom, so nothing cancels out, we still have a negative value. Alright, can you guys, do you see a difference between those 2 slopes that we just found?
One's negative.
Yeah.
One's negative and one's positive?
Mm-hmm.
Do you think that's gonna come to represent a different graph? If we graph them out? Maybe? Well, let's try it.
Probably, if they're different.
Yeah.
Alright, so we have the point 0, 2, and we have the point 1, 4. We draw a line through those 2 points. So this is with our slope of 2. And we come down here, so we have the points 1, 4 again, and the point 2, 3.
Yeah, different.
What do you guys notice about the graphs?
One looks like it's pointed going uphill, one looks like it's going down.
Yeah, the top one looks like it's going up. Oops. Alright, so what that's going to tell us is if we have a positive slope, the graph moves upward from left to right. Is the description of that graph. And if we have a negative slope, then the line is moving downward from left to right. So both times the movement starts on the left and goes to the right. When it's positive, you're going up because you're adding to it, you can think of it as. And when it's negative, you're going down. So make sure you guys write this in your notebook really quick. So now let's try another example and see what we get. We have the points 1, 2, and 3, 2 let's walk through this together really quick. We get m equals, what one do we want to be our x1, y1? Which one do we want to be our y2, x2, y2?
We made 1, 2, x1, and y1.
Alright, so when we plug it into the equation, we get 2 minus 2 over 3 minus 1. Do we all agree?
Yeah.
Yeah. So we end up with 0 over 2. And we know 0 over anything is just 0, right?
Yeah.
So we end up with a slope of 0. That sounds kind of funny, right? How do you like not have a slope of something? What do you think the graph's gonna look like for that?
Just a point?
What do you think, John?
So is it just a point?
It's just a point. Well, no, because we do still have a line. We just don't have a slope. So let's try to graph it out. Alright. So we have our point 1, 2. And we have our point 3, 2. And we connect those lines, the dots. And what kind of line do we end up with?
Horizontal.
A horizontal line. So that shows us when we have a slope of 0, that means that there's no vertical change no matter what the horizontal value is. So the y value is always staying the same no matter what x value you have. So then back in our objectives, we talked about 4 different types of slope. So let's see if we can find the last type for us. So we're going to use the points 1, 3, and 1, 1. Gary, do you want to come up here and solve this for us?
Sure.
Good job. So when we see that the slope comes out to be negative 2 over 0, we can't have a number over 0, can we?
Mm-hmm.
No. So what happens with that slope? Since we go and we draw this graph, our slope doesn't exist, is what the formula has told us. And we go over here. We have the point 1, 1 and 1, 3. So when the slope is undefined or doesn't exist, we end up with a vertical line. That means that there is no horizontal change no matter what the vertical change. So in this case, the x value stays the same no matter what your y value is. Alright, do we all have that written down in our notes? Okay. So first by yourself, I want you to write down 1 through 4. And just by looking at these graphs, I want you to write down whether it's positive, negative, 0, or undefined for the slope, using the characteristics that we just done. you get done, you can talk with your neighbor. Alright, so what is the slope of number 1? Is it positive, negative, 0, undefined?
I said undefined,
Undefined, yeah. And how do you know that?
because there's no horizontal change.
Correct. So we have undefined. What about for number 2? Colin, what are you thinking?
I had a negative.
Negative?
Yeah.
Alright, and what's your reasoning behind it?
The vertical change is negative.
Yep, and we're going downward, right?
Mhm.
That downward slope from left to right. So that's how we get our negative. Alright, John, what do you have for number 3?
Said it was positive.
Positive? Why do you think that?
It's going up to the right.
Yep. And Colin, can you do number 4 for us as well?
I had 0.
0?
Because there's no vertical change at all.
Yep, it just gives us a nice horizontal line. Alright. So now let's take a second and look at a word problem. So I want you guys to draw a picture representation of this problem here. So the bottom of a ladder is 4 feet away from the house and it reaches a height of 16 feet on the side of the house. What is the slope of the ladder? So take a second, draw a picture. Make sure the bottom of the ladder is 4 feet from the house and it reaches 16 feet up on the house. So you want to go back to our rise over run. So if we come here and we draw a picture, got a nice ladder on the side of our house. And we know that it goes over 4 feet away from the house, right? And we're going up 16 feet. So John, which one did you make your rise?
16 feet.
Because we're going up the house, right?
Yeah.
Alright, so if our rise is equal to 16, that would make our run the 4 feet, right? Alright, so then we plug it into our equation. What's our slope ratio?
It's rise over run.
Rise over 1. Right. So we're putting 16 over 4, and we're ending up with a slope of 4, right? Alright.
I have a question,
Yes.
2 questions. First question is, on another slide I have in my notes, that you say that in order to find the slope, we need 2 points. I don't see 2 points there though. You just have 16 and 4.
Well, this isn't using points, it's using distances.
Okay. Could I make points out of that? Think about it. You have your coordinate axes there.
Yeah.
'Cause I need points. What would my points be then?
So we'd put
4,
0, 16, and 4, 0.
And what?
And 4, 0?
What?
Oh, no, right then.
Okay, so we can impose a coordinate system on a lot of problems, right?
Yeah.
Ooh, analytical geometry from history of math.
That
And
class
then
comes
my,
later.
what's that?
That class comes later.
Cross curricular. And then my other question is, what is 4? 4. So the slope is 4. What does that mean? 4.
That means it's the steepness of the ladder.
Okay. What does it mean that it's 4? It's just 4. So is there a unit attached to it? It's 4.
The feet cancel out.
Okay. But the ratio, so we just say the ratio is 4, but is there a way that I can make sense of 4 with respect to units? You say the feet cancel, but another way of looking at that is, so actually, when you wrote 16 over 4, put 16 feet over 4 feet. Feet over 4, so you might say the feet cancel, all right, so 4. But maybe the feet don't cancel. And maybe 4 is 4 over 1. And so instead of writing 4, it's 4 feet over 1 foot. Okay? So thinking about that, 4 feet over 1 foot, what does that mean? This ladder is going, John knows this, by the way, up 4,
For every
right?
1 foot over.
For every 1 foot.
Well,
Go ahead, Gary.
if you flip the ladder on the other side, it maybe it's.
Right, you could say that. It would depend, and really depending on how you're looking at it, if you're climbing or going up, right? Because John and I both know something that you don't know. We've been on roofs that have a 312 pitch that are pretty easy to walk on, and an 812 pitch that I need a rope with a person on the other side, right? Or something, because when construction people say, hey, that roof's 312, John, what's that mean?
It goes up 3 feet for every 12 feet it goes in.
Right, so it goes up, so that roof is going up 3 feet for every 12 foot of a run.
Okay.
So that means an 812, picture an 812, right? For every 1 foot of a run, you're going up 8 feet, which makes it pretty steep, right? See, I knew my construction day would come in handy. One time we built a roof
Figured I could
one time we built a roof over an outdoor pool that was half 12, just for rain, right, to come down. It was half 12. So anyway, all right, finish up.
Okay.
So do whatever you're doing. Sorry.
I just haven't closed it.
Yeah, I figured so.
All right.
Because I'm looking at your objectives, and you've done a good job of following your objectives. Go ahead.
Thank you. So in closing, let's review. So what formula do we use to find the slope? If we have 2 points, what formula we're going to plug it into? Colin?
y2 minus y1 over x2 minus x1.
Yep. And does it matter which point we make the x1, y1 or the x2, y2?
It doesn't matter which point, but it matters, like,
That you keep
Yeah.
them together?
yeah.
You just want to keep your order pairs together, that's correct. Alright. And what's the ratio that makes up slope for us? And then we just gotta look, we have the graphical characteristics, so we know if it's positive, we're going upward from left to right, negative, we go downward. If there's no slope, if the slope is 0, we have a horizontal line, because only the x values are changing, not the y, and if there is an undefined slope, we have a vertical line, with only the y values changing. Alright, so if you take out a piece of paper really quick, we have a ticket out the door. I want you guys to find the slope between the points 1, 4 and 2, 3, and also describe what the graph of that slope would look like. You don't have to draw the graph, just describe what it would look like.
Since we're here on this right now, I do want to point out that when you say describe what the graph of slope would look like, I'm thinking as a teacher, describing, I don't wanna just, I don't think you're after me just saying, it's positive, negative, 0, and fine.
Yeah.
Is that what you want?
Well, that and
Or
like,
do you want us to just say it's falling left
the
or right?
characteristics.
Or it's going downhill, is that what you mean?
Yeah.
Yeah, I mean, and I say that just because I think both are fine, but thinking about her lesson, we didn't really practice describing it.
Oh,
You know what I'm saying? Like we said positive, negative, whatever. I don't know that I would call that a descriptive or a description, unless you're just going to say for this problem, tell us whether it's positive, negative, 0, and fine. But when you say describe, I feel like you want a little bit more. Like
Okay.
it's falling, it's rising, is there something like that? And so I'm thinking back to the lesson, I'm thinking, we didn't really do that. You know what I'm saying? We said, but we didn't really do it for any of our problems. But... Oh, that's good. Done? Good. Good. All right.
I found a good picture for the next class.
Oh no, what? Wait, for next class. You can probably next class we calculate the slope of how downhill my life is going. Now the finals week is upon us, right? That's good. How quickly, you know, that's not bad. That's not bad. You could say describe. You know, describe. Give me 2 points to show how fast your life is slowly careening towards the.
It was like useful things that form next one.
That's funny. Well, so my initial observations, and it's not like I didn't think this probably about Brittany, just knowing Brittany over the last couple of years. Besides the fact I never thought she would turn and submit her MATH200 paper during head psych.
I wanted to get it in.
I've seen you.
It was the first.
I got it, and I was like at 8:10 or something like that.
It was 8:05.
8:05, so I sent an email back and said, I got it now. Pay attention in that psych. Anyway, but my first impression was that, you know, for Brittany, you will have to get a little, and it's a long way to go before student teaching and getting your first job. And there's a lot of people that will piss you off in the middle of that, which means, you don't understand what I say, you need to become more authoritative, right? Just think about, when I say that, you know, just think about all the people who pissed you off in life and just take it out on your students. No, don't do that. That's a joke. But, what's that?
That's what John
Sometimes. No, but, and I say that because it's easy, and this is impossible for us to, you know, mimic in here. You know, we can pretend like we don't understand things. We can pretend like we're disrupting, you know, the class. But in reality, you know, we're not doing it, you know, as well as your students will. So some of the things that we do, and obviously here there were 3 students. And one of the things I'm saying is make sure when you give your students a problem to do, you have to hold them accountable by doing, well, hold them accountable and do something. There are 3 things that I say you do. You walk around the room, okay, for 3 things. 1, hold them accountable and keep them on task, okay? Here, it's really easy to just glance, is everybody doing their work, right? But when you're doing that, you can keep people from fooling around, because if you just stand up on the board and do something else, you're drawing pictures, like drawing your graphs that you were doing, half your students are probably not going to be doing what you're wanting them to do. So you walk around to keep them on task and hold them accountable for actually doing stuff. Second thing that you walk around for is to assess their understanding. So we don't talk a whole lot about assessment in this class. We will in block 2, but assessment, one of the types of assessment is formative assessment, which has the root word to form my instruction. So I'm walking around seeing who can do what, trying to catch Colin's mistake, so I can adjust my instruction for Colin individually if he's the only one making that mistake. Or adjust it whole class if I see lots of people are making the same mistake. I say, stop working right now. Everybody's doing the same thing. I don't want you to practice poorly. Practice doesn't make perfect. Perfect practice makes perfect. Don't keep practicing the same darn thing. my son yesterday, or 2 days ago, he was playing, what song was it? Oh, Susanna or something like that. And he was getting frustrated every time. There's one place, he was just doing it wrong. And he kept doing it wrong, you know? And then I was like, you know, go move on to another song. Because don't practice that song anymore. I didn't know what he was doing, you know. And then last night he was practicing the same song, and he said, and he yelled up, he said, Dad, it must have just been yesterday because I'm doing it fine now. You know, so you want to just stop sometimes. Stop practicing what you're doing. Now, I can't fix his music issues, but I can fix his math issues, you know. So you're in that same boat. So sometimes we do that, but you walk around to keep them on task, to monitor what your students are doing, and to adjust your instruction. Maybe individually, maybe whole class. The temptation here is, you know, I stand up here, it's okay because they're all doing the work. But he made a mistake up on the board. You don't want to catch him making the mistake up at the board. You want to catch him beforehand. So kind of, you know, think about that. You know, you did a good job of explaining things. Again, you're probably gonna have to come out to be more authoritative because your students aren't gonna listen to you as well as, you know, they won't listen to you as well as we listen to you, if we're listening to you well. And they won't listen to you as well on the third day as they will on the first day. Everybody has a great first day of school. And then about the third day, it's like, these kids are driving me crazy. And I found it interesting, and this is, no matter how good a lesson goes, your first time you teach it, don't ever settle and say, oh, I'm going to keep that lesson plan and use that lesson plan again. My advice is, first time you teach a lesson, you teach the lesson, and then crumple it up and throw it away, and create it again next time. Okay? Now, if you want, you can keep it, but I would never suggest the first time I go through and teach a particular lesson, that the next time I teach it, I just go back to my lesson plans and say, hey, that's a perfect lesson, I'm going to do it again. Who the heck is perfect the first time they do anything, right? 26 years later, I'm still looking for the best way to teach slope of the line, all right? So what I say is, you know, you did a very traditional thing that we would see in textbooks. And remember, the textbook, we've talked here and in history, right? The textbook is a finished product, right? A nice, neatly organized set of, you know, thoughts. That's not how life is usually, all right? So what I found interesting about taking that is she introduced the slope of the line formula, which, think about this. We usually do, with this topic here, we usually do the algebra first because we want to get to the equation of the line, or the equation of the slope formula. And then we show the geometry, the points, right? And talk about rising, falling, and that. But think about history of math. Which came first, the chicken or the egg? No, geometry or algebra? Which was our first from a historical thinking? Geometry, right? Everything was geometric. So why don't we? And I'm not saying that it would have been a better lesson. I'm not saying that she should have done this. I'm saying it would have been a different lesson to say, hey, plot these points. How are these lines? Are these lines rising, falling? As we look left to right, are these lines rising, falling, not rising, falling, or not even rising? Okay, from left to right. And you know, let's talk about that for a little while first. Then move into the algebra. We all did well in math probably because we got really good at manipulating symbols pretty quickly. And then we thought we were good in math because that's what the focus is in high school math. But don't forget about that geometry too. Again, that's just something to think for next time I teach that. Maybe we should graph the points, or even this. You know, she did an example, you did an example, and then she said, try these two on your own of just getting the slope. And then, after that, then she said, here are two more problems. She wanted you to just find the slope. Then she wrote axes up there, drew axes up there. And then after you found the slope, then she said, let's plot these, because she knew she was moving into rising, falling, positive, negative, zero, undefined slope, right? Why not look at it all together, right? Why not say, hey, plot these 2 points. Is it rising or falling? Let's find the slope. You see that? I mean, it's a good way to combine everything instead of, the textbook can't do that, right? That's your creative license that you get. You know, I'm not a very creative person when it comes to just, you know, my life, but when it comes to when it comes to teaching a lesson, you know, I think it's it's my, I'm not saying it's great, I mean, it's my masterpiece, right? It's my you know, masterpiece that I'm putting together and get to create. You know, so I look at a lesson like that. How am I going to put it together? I don't want to just provide information, especially for kids. So even though, you know, I thought her lesson was pretty good as far as like investigative, inquiry based. You know, she did lead us through some inquiry into the topic. That's good for our level of like university, because you don't have time to create activities. But again, another way, keep in mind, can I give my students more stuff to do and me less? Now, it doesn't necessarily mean I have to give them a worksheet, a guide sheet. I don't want to say worksheet, a guide sheet that says, do this, do that, do that. But I can stand up at the board and say, here are 2 points. You know how to plot 2 points. Everybody plot them. Connect them with a line. Let's talk about whether this rise falls. You see, they're doing it. And again, it's time consuming for me to create an activity guide sheet to do that. That's why some books have already done that for you. And everything is taught as an activity. I like those books. Unfortunately, when I see how those books are used out in the field, they're used more for the teacher to do most of the work, when they're supposed to be for the student to do it. It's their activity book. They're supposed to write in them and do that. So it's already done for them. I don't have to create that. That's time consuming, but I can certainly do that at the board and have them, you know, kind of do that. So a different way to kind of look at it. You know, one of the main things is, and I said this before in somebody else, I think it was actually Maddie's. I might recall, I think Colin might have done a little better job at it, but then Maddie's, you wrote a lot of problems on the board with no directions, right? And so when I go back into my notes, and there might be 3 or 4 things in there, or I'm mixing it up with yesterday's lesson and the previous day's lesson and the next day's lesson, I don't know what the heck I was supposed to do with those 2 points. Now, I see there's 2 points, and you did something with them in a formula, and I see the formula over here that says slope, but then I'm forced to make that connection. Find the slope of the line between the 2 points, and tell us whether the slope is positive, negative. You did it when your problems were up here, but when we write the problems, I know we get lazy because it's a lot to write, but it needs to either be done here or something really focused on the notes. And keep in mind, I always, and I do this too, I know when I watch myself on tape, I do the same thing, but usually when I see dumbfounded faces on my students, then I think, oh, that's probably a stupid question, because I'm probably more aware of it than you are. So she asked this question here. Just be aware of our questions, and be aware that you know what your question is and what the answer is, because, well, dang it, you made it up, or you saw it in a book and you're using it. But she asked this about after one of the examples, in which she had 2 more problems. It was the 0,214 and the 1,423. So the one was positive, one was negative. So she says, do you think these 2 will have a different graph? I want you to just think about that question. Because Gary actually said, of course they're going to have a different graph, they're different points. And that's not what she meant. She meant, is one going to rise, one going to fall, right? So if that's what you mean, then ask that specific question. But maybe you didn't even need to ask that specific question. Maybe it's just, hey, let's graph these 2 points and see, graph the 2 pairs of points and see how they differ. And that's it. But just to say, are they going to differ? Well, of course they're going to differ. One's going to have those 2 points, and one's going to have other 2 points. The only ones that wouldn't differ, right, would be 2 points. Well, let's see, hold on. I have to be careful with that. I was going to say 2 points, and then another 2 points that had the same slope. That's not true, because they might not be. They just might be parallel, so they would still differ. But I'd have to find 2 points, and then use another 2 points that exactly, or have the same line. That'd be the only way they didn't differ. I always do think it is funny though how we, and again, it's not bad, it's the way that we're all a product of our environment, right? But it is funny how we tend to force the manipulation before the geometry. When, I'll say 2 things. Historically, geometry, we know geometry came first, but you guys did all just read, I can include you because Maddie's not here, but all of you just read the history of geometry, and remember what it started talking about at the beginning is that at the beginning it's all very intuitive and very intuitive, very experimental. And it even made a comment there, when you're teaching geometry, and I found this to be very effective when I taught several years of geometry, is I would always get behind all the other teachers at the very beginning of the year, because I spent a couple weeks just playing. I looked at but as many concepts as I could that I was going to get over, and we just played with them first. So very experimental, and I don't know if I want to say intuitive, but what's the word that the book used? They called it scientific geometry. The term is lost my mind here. The very first level. But anyway, just kind of playing with it first. You almost always should play with stuff first. Well, yeah, you think about that as in a geometry class, but if geometry came, if everybody, I don't want to say everybody's a visual thinker, right? We know that that's not necessarily a good word, but using the visual mode of learning is always a good way to learn. So why is it that we don't, when we're teaching, use that geometrical mode? Because knowing that in my class, most of the people aren't going to be the algebraic manipulators like I am. So that's kind of challenging for us to maybe think about. No, that's good. It's good.
How to pay for it.
Yeah, this is my last. I have one more page. I guess you can. I have more books. All right, so that's good. Well, I've got many more of these books. So don't you worry, Joe. Last day of class is Thursday. All right, the only thing I want to go over after this was to look at your small assignments. The only one I didn't get over was the Excel. Any questions though on the other ones that you want to ask now? Folks, don't forget books. You have books. You did forget them.
Well, we still have to do a narrative PowerPoint.
I won't give you.
Oh, yeah.
So if you need a reference, you don't have to use that book, but you can use another one or get something.
You also said we do these online, so.
Yeah, you can use it online, material, or whatever. Any questions about the other assignments? Most of the stuff's pretty straightforward. Like I said, it'll take a little bit of time, but it won't be hard. Good teacher, by the way, always erases their board. What's all right, I'll give you that. You have a student do it, right? Will you please erase my board and clap my erasers?
Go, Johnny.
All right, let's see. Yeah, I didn't go over these very carefully, but the video critique assignment, again, keep in mind, you don't have to answer all the questions. They're just prompts, but at least it gives you some kind of starting point for how do I critique myself. I just look at it really in the two different areas here, public speaking and then some educational mathematics education aspects. When you read my critique, if you want to call it, on your lesson, I address your communication aspects, so I can address some of that stuff, and then I address what I call pedagogical aspects, which is really how you're teaching, so educational mathematics, educational content. So when you're looking at your public speaking aspects, think about your voice quality. Was it strong? I wouldn't necessarily say yours was strong, right? But it'll get stronger. It'll get stronger. You'll get more confident. Students will piss you off more, and you'll learn. And you'll become a parent, and you'll learn to yell. That's what it is. And your kids will learn to yell. The little one last night stormed up the football field in our backyard. I hate you! Because what did I do? What did he do? He pounded on the back of my older son, and then the older son did something to him. And then I said something about, he was just retaliating, and he got really mad. He stormed up. I hate you. He has anger issues. Yeah. Any annoying gestures or mannerisms, eye contact. Did you look like you were comfortable in front of the classroom? Things like that. And then mathematical educational aspects. Did you let the students know what they were going to learn in the lesson? Objectives and that. How'd you introduce and close the lesson? Were you writing things down or simply making verbal statements? So obviously I would expect Brittany to comment on, I really didn't give any directions. I just put random things up on the board and said, do this. And of course it makes sense because I'm doing exactly what she just did. But 3 hours later, at the end of the day, I'm at home. I'm not gonna remember that. Did you ask questions? Were they open-ended? Were they closed-ended? Did you use visual aids? Did you move slowly enough? So how was your pace? And a lot of it, comes from my marking as well. So. Nothing too much. One page, probably. If you're going double space, doesn't really have to be. It doesn't have to be double space, but how are we going to do it? Because you're gonna put it in the live text editor anyway, so you'll copy and paste it in there, so you won't know that it's one page. All right, let's look at the spreadsheet. So this is not difficult to do, and again, you can work on it together. I prefer. There's no way for me to check this. I prefer not to have one person just do it and share with everybody. Excel is just a tool that you can use. I still use it to keep my grade book, even though, well, for me, it's what I need. And sometimes, teachers still need something, I think, hard for them, but so many times nowadays, your school district will have an online system where, and the bad thing is, like, we don't have access to it, to any, because they cost quite a bit of money to do. And then your school district will expect you to use that because it's a way. I still get notices on my phone that when a teacher uploads a grade, I get notices on my phone about what my son's grade is now. What he just got, and then what the grade is. So schools want you to do that for parent purposes, and it makes report cards really easy. It was my very last school I taught in, was the only school that I did any electronic, and it was nice because I could go in and say, okay, I'm gonna make a category of homeworks and make it be 15% of their course grade, or make a category of quizzes and make it be 20, tests and things like that. So that was nice. And you're expected to use that, now anyway. But Excel is still a decent program to use these things. Okay, so when you look at this right here, I have some certain criteria. Okay, you're going to have 15 students, so down here, whatever. And you have some creative license with this too. So you're gonna have 3 exams, 5 quizzes, 7 homework assignments, and 2 projects for each student. Now, for you, because you're created like this, so if I knew I was creating a course and it was gonna have 3 exams, 5 quizzes, 7 homework assignments, and 2 projects for each student, I might do this. I might come and say, so what did I say, 3 exams? So exam 1, exam 2, exam 3, and then what did I say, 5 quizzes? 5 quizzes, so quiz 1, there should be 30 in this, right? Quiz 2. So if I knew I was going to do that, and then just going to do 1, 2, 3, 4, 5, 6, 7, project 2. So if I knew exactly what I was going to do ahead of time, I could set it up like this. In reality, for me, I am the type of teacher that even when I've taught a class for multiple times, I usually build my assessments kind of as I go, just because I do different things. I say different things, something else comes up in class, I'm like, well, no, I want to use that. And I want to give you a little quiz on that tomorrow. So I do, my spreadsheets are chronological. So, you know, homework 1, homework 2, quiz 1, quiz 2, test 1, and then when I'm having it compute the average of the cells, you know, then I just pick and choose. You guys know a little bit about Excel, right?
Yeah.
No, a little bit. So when you're doing Excel, if I want the average, let's say, of these 3 quizzes, I can do one of two things. I can either say, give me the average of this, and this, separated by commas, or I can say, give me the average of this through that, separated by a colon, and then it'll take them all through that. And none of this is so sophisticated that you have to Google how to do things. So when I have one that I'm going to drop the lowest grade, there's a command that looks at all of them and drops the lowest grade. But I always have to look that up. It's not common knowledge. I don't use it all the time. So, but these just figuring out averages and percentages and weighted average, you know, this is all pretty straightforward. So obviously, if I have an exam here, an exam here, an exam here, and I can't go from this to this cell. I have to say this one, this one, this one. Okay, so then I look at this, or this would be my building of it. So what's it say here? These, the average. So consistent with these. Spreadsheet should show then the average of the exams, quizzes, and homework assignments. Okay. So the average of the exams, quizzes, and homework assignments. Now, if you want, I don't care. You can insert a column here and say exam average, and then do the same thing after quiz. That's fine. Or you can come all the way to the end and say this is my exam average. I don't care. Okay, doesn't matter to me. Whatever makes sense to you. Creative license. And then of course for the average, and again, I assume you know what the Excel. If you don't, you can certainly come in and talk to me. You can ask somebody else, whatever. But if I need Excel to compute an average of 3 things in this case here, I'm going to be in this cell. This is where my exact average is. So let's say student 1. So in that cell, if I want Excel to compute the average, then it's a formula, so I have to hit equals. Okay, and then I just want the average of it. So I just type in average of, and again, it is what? It's in B2, so B2, and it highlights them. So if I hit colon, D2, see it does all of them, whereas if they're in separate places, B2, C2, D2, it just puts them in different colors. Yeah, I don't do that because I'm kind of old school and that's a newer thing. But yeah, so you're saying what? You can do average and then what? I click there, there,
Drag.
comma. Well, if I hit comma now, then if I do this. But you can drag too.
I think, yeah.
But again, mine are always separated, so I don't. And usually I will look at my spreadsheet and write the thing down first, because sometimes I'll have a long spreadsheet that's off the thing, so I have to write things down. No big deal. Anyway, so I do that, I get an average there. Now, I usually do this as well with different, I round the average to 2 places, whatever. And then if obviously that's a nice one, right? If it's 70, but if it's point they're round it to 2 places. You do the same thing with the quizzes and all that, okay? So then it says, so get that. Now the student's final grade. So it's a weighted average here. It's not that their final grade is not the average of all of their scores on things. Their final grade should be computed by using the average of the exams is 50%, the average of the quizzes is 20%, the average of the homework assignments is 10%, and each project is 10% of the grade. Okay? Now, so this you pretty much have to. So there's it's however you want to do it. If you put exam average, then quiz average, and homework average, then you're going to have to come back and see what cells those are. If you have them all right here, at least they'll be right there. Okay? No big deal, either way. So when I say this, I might say this is my course average. And for here, I will have to do this. Hopefully you know how to compute a weighted average. So I would say equals, and none of this is going to make any sense because it's not filled in here, but this is my exam average. So that is E2, so I'll say E2, but it is that's only 50%, I think it was. That's only 50% of your course average, or your course grade. So I will multiply that by 0.50, all right? Then I add to that the quiz average, wherever the heck it is, all right? That is 20% of the grade, so I'll multiply that by 20%. Homework is 10%, each of the projects are 10%. That'll give you the, whatever, 76%, okay? So, yeah, of course it's now, the other thing, the last part of the spreadsheet that I want you to do is, in addition to this information about grades, spreadsheet should show the results of a pre and a post test for this course, whatever it is. Okay, maybe it's just a 9-week period, whatever. So at the beginning of this time period, I gave a pre-test of all the things that they are going to learn, and then I gave them a post-test to see what they knew. I gave them a post-test afterwards to see what they knew. So what you want to do there is, and then we'll compute what's called a learning gain. All right, so we're going to talk about learning gain first. So the learning gain is this. I've given a definition here. It's the percentage that was gained from pre to post out of what possibly could have been gained. So it's obviously a ratio. It's a percentage. So it's a ratio there that was gained from pre to post out of what possibly could have been gained. So what I mean is this. Let's say that my pre-test was a 32%. I don't expect very good grades on a pre-test because otherwise, why teach? Post-test is 82%. Okay. Now, they gained from a percentage point wise, they gained from 32 to 82. They gained 50% as a number, right? So of course, how do I figure that out? It's 82 minus 32. Now, that is out of, so they gained 50 percentage points. But it's a learning gain, so they didn't gain 50%. They gained 50% out of what they could have gained. They couldn't have gained 100%. So it's not 50%, because 50% is 50 per 100. So they didn't actually gain 50%. They gained 50% out of what they could have gained. How much could they have possibly gained if they started right here? Yeah. 100, that's all, minus 32, 68. Okay? They could have possibly gained 68 points. They gained 50. Okay? So 50 out of 68 is 74%. They gained 74% of what they could have gained. Okay? So on a spreadsheet, I would just say something like oh, come on, I know I screwed up. Okay, just let me That's a bit pissing. So I'll say pre, post, learning gain. Okay? Well, pre, whatever, I'm going to use those, 32, 82, and this will be what? Equals, and then what's my numerator? My numerator is post minus pre. So what does that apply to? Minus x2. Out of, always 100, minus my pre is x2, x2, that's it. Oh, what does it look like? What does it look like?
Is
Oh, there's no parentheses right there. I didn't parentheses. I didn't listen to the actual thing. So now that's going to give me that, right? Well, you know, let's actually do something here. So think about it from here. So I'll multiply that by 100, right? And of course, what's that give me? That thing. Well, I don't like that. So I'll just come up here and say round that mess to 2 and do that. Something like that. Okay? So turn around with that and we will, and that's actually, ooh, that is your last assignment there. So in closing, hopefully we are all learning from each other with your peer lessons. We're all in it together, so do not think that, oh, this person did a better job than I did, because maybe they did it 3 weeks after you, and we've been talking about all of their terrible mistakes. So we are in this all together, so you're not isolated. You know, kind of disturbs me when even yesterday, talking to a cooperating teacher, and obviously I don't have any leverage with my cooperating teachers, but she wanted the student teacher to like create more activities that would do this through combination and permutations. They were studying that. I'm sitting back there thinking, then plan with them and say, let's do this, instead of, I think sometimes the cooperating teachers think that you're supposed to have all of this ability and knowledge to just go out and use it, and then their job is to just evaluate you. And it's not. Their job is to provide you with this experience and help to be able to do it. And then finally, get to work now on your final project. So, oh, semester long research papers. Somebody's already given you theirs. And then, yeah, everybody. I'm trying to think of all the rest of you who will be doing your history.
I just didn't email it to you.
You just need to remember the work site.
Yeah,
Okay,
I know,
anyway,
it's
all right, that's
the
it.
second time I've done that.
Yeah. Yeah. I was like, what is he sending me again?
Dude.
We have its
We're
number.
gonna miss you
I
for
didn't
so
want to talk.
long.
You what's that?
We're gonna miss you for
Oh,
long.
yeah.
Oh yeah, I'll be texting you over the summer.
Oh, no, you won't.
Sounds
And I'll be ignoring you over the summer.
Hey.
That's not true.
Hey.
I'll email you back.
Hey, Steve.
Yeah, well, that's all it says. I will be ignoring you.
Is there a way where you can like get a printout of all the
Yeah,
blanks
take
and
the
the
photos.
yellows? Because my
Answer me on the